So guys, what you see here is actually the result of this video. I'll show you here in a video. Actually, it's gonna be two parts because it's too long. First, a little bit of theory, why and how to build an external battery to a Onewheel one, which is also interesting for the Onewheel Plus and actually for the Onewheel XR, even though the difference is the internal battery of those Onewheels. But I'll come back to this during the video. So this is my first video of Onewheel battery build, and actually this is my probably my first real battery build ever. So if you're interested, it's a quite long video, but I'm trying to cover everything from theory over planning into building, test running it, and the summary. Have fun. So welcome to this video. It's a DIY tutorial about a battery I built for my Onewheel version 1. I have to give a summary about what I think I know about this batteries in the version 1 and in the other versions. So what I know is that in version number 1 there's a 16S lithium LiFePo4 A123 lithium works battery cells in the box in the Onewheel, and this battery is can be replaced. I have a used board now, and it's not running very far anymore. So I thought about putting in new batteries into the board itself, but I think it has still 70-80% or 80% of its original capacity, so it's not completely useless. And what could I expect? Yeah, to just gain another 20%. But of course, the Onewheel one has not a great range, so many people play around with range extenders. So I thought about buying a range extender. So in the end, for me, the only option would be to really plug it into the charging port, the XLR plug, because I don't want to open the board, and I don't see any bigger advantages of directly connecting the two batteries, because there's a lot of current running between the two batteries then, and this is something I think people don't really take serious enough. So by putting it into the charging port, I think it's more safe, easy to install, and easy to remove. And you will have an external battery. Yes, this is what you get with a range extender. There's this range extenders you can buy on the internet. It's more like a cradle to take the, for example, the Evo battery. This is a 56-volt battery running also 14S lithium batteries. One of the Evo batteries in 5 amperes is about, like, in Germany, 250-300 euros, and then you still need the charger and this slider that takes the battery and the cable. So it's certainly a 500 euro upgrade for a range extender of, let's say 10 kilometers. So I thought about building my own. It's not really complicated, but I didn't want to have something putting in my backpack or putting a box on top, like a battery on top of my fender. So I came up with this here. So that is a drawing of a battery holder. It's a box, a complete box. You can see here on the table there's this is just 2 centimeters printed in a resin printer, in a any cubic resin printer of this here. Actually, it's a battery holder in the beginning to make the assembly just a normal assembly, right? It's a 14S. This battery is called BAK N21 700 CG /50. I'll tell you more about the battery later. So this takes the 14 cells. There's a normal standard BMS that can do 30 amps out. Well, we need 3, 4, 5 amps, officially 3.5 amps to put into the Onewheel. So that's fine to have a small BMS. I couldn't find a smaller one. I would have taken a smaller one if possible. Yeah, they're just normally in series, so you end up with 14 cells. This is actually everything of the build, and of course I shaped the box. You see here, it's the holder of these 14 batteries. They're already glued together, so I just take it out of this cradle and just push it into this one here. These batteries are that's going to be glued in a little bit to the bottom, because they have no structure above to hold them down, but they are all glued together. So, and on top there's a BMS area in here, and then there's a little window here already made for the volt indicator, for the voltmeter, and there's a little hole in here that will take the XT60 plug socket. Yes, this is the build. I'll tell you a bit more about this. Actually is printing in the moment in my workshop. We'll show it to you later, and I will put it into the box together in this video, hopefully. We'll see. What I wanted to say about why did I take lithium battery, and what is the advantage and disadvantage of a lithium 14S battery as a range extender. Therefore, we have to look into this sheet here. You'll see here on this left side there's everything about this particular lithium battery, the BAK 21700, as mentioned before, 5000 milliamp. So inside inside the Onewheel there's a 2500 milliamp 16S LiFePo. So that's a LiFePo here. It's a 8123 123 with 2500 milliamps, and this is the size how it's built. Size 26 millimeters in diameter and 650 millimeters long. And yeah, and a full charged LiFePo battery has 365 milliamps. Times 16, you end up at, sorry, some mismatch. There's an old version in here. I'm just going to correct this. So here, you end up with 58.4 voltage when it's completely full. The official normal charger of the Onewheel comes with a 58.8 voltage to charge the battery, and it will shut itself off when the current goes under below 0.3 amps. So I reckon, well, it's made for this, so it's interesting that it's 58.8, the charger. Maybe I'm going to make a picture and just blend it in later. So fully charged, empty. And I mean, like, this is, whoever knows LiFePo, this is critical empty here. Yeah. So in total 40.8, 40.7, 40.6. Well, this is when the battery really, you see it here, at the red line is a discharge line. Where it drops below 3, it really goes down, right? And this is not the graphics for this particular battery. That's why it's only stated 2.4 down here. Okay, don't be irritated. This is not for the A123. This is a standard LiFePo4 battery, but it's just about like, so you see everything here is in between 3 points. So at the beginning it drops rapidly until it hits somewhere 3.33 maybe, and then it continually goes down until it goes to 3.2, 3.1, and then it drops. So everything, 80% of the drive, you will be of your ride, you will be in between this and that. So you're in between 52 and 49. So actually when I have the voltmeter on my board, and it rapidly leaves 54. In the beginning it's somewhere 54, because at the moment you start riding, your motor draws voltage and it drops, so it's 54 in the beginning, and it rapidly goes to 52 and 51, 50, 49, and then it really goes quickly down to 48, 46. And this is actually what you see in your app. This is from 100 full to 0. Yeah, so there your board stops driving. It will warn you. So what do we do with the range extender here? So the range extender, first of all, we're talking about 14 cells that are full on 4.2 volts. That gives you 58.8. This is actually what the original charger of the Onewheel does. It's a good coincidence that 14 times the LiPo is the same like 16 times the LiFePo, roughly, but very, very close enough. So the moment you plug in your this battery here on the charging plug outside your board, it will start charging this battery. And it will charge it with 58.8, like in the ideal world. But of course the motor is running, so it will be it will all go down to 54 point something while you're driving, or riding. So I would strongly recommend to plug in this this range extender once you are below 80 maybe. So that's early enough. This is don't plug it in too early, otherwise you get some warnings that it might overcharge. So here you see the range of this battery. The full one. This is also 100% of this battery. Well, I can mark it for you. So we see here, if I put this one green here, or I put it in orange. Look, this is what you can use to charge your other battery, because once you're below a voltage of 3.3 in this battery, which is about 30%, 40% of the LiPo left in there, then you're too low to charge this battery and to give your control board in the Onewheel the information that you have enough current to keep on riding. So as said, if you're here on 60% of your, or 60-70% out of your battery, then you might still have 20-30% left in the LiPo, and you will finish your ride with a non-emptied battery. This only way to overcome this situation would be to boost the voltage on this battery here at that moment, but then you need a booster with 3.5 amp. That is another block of this size. Could be interesting for some people. It would be could sit on here. Probably it would raise, and then the complete box by this size, and then this package would always, until it's dead or empty, would always give out 58. You could set it to 58, a booster, and then you could discharge it completely, which would be nice. Maybe I try it another day. But at the moment, you can only use 70% of this. Why do I do this? This battery goes by, you can buy it by probably €4 a piece, 14 times. So that's a little bit more than 50, maybe €60, only the batteries. That's a €20 BMS, it's 80. Some resin to print this, other 10, €15, a few cables. This one is a €1 piece, this is a 20-cent piece. So the whole battery, just the materials are €100. So I compared it to the Evo, to this big block battery from machines, from like household machines. This you know them, the Evos, this big block green ones, and and it's like maybe 1/4 of the price of the Evo. And actually, even they sell this range extender with the Evo for the Onewheel 1 and Onewheel 2. It will do the same, right? It's also a Lipo battery, and it will also be at a certain point, it will be too low voltage to charge your LiFePo battery. So for Onewheel 1 and Onewheel Plus, which I think is the same battery as I know, this one inside the board, this is a good solution. The other solution you would have is to go with the original A123 batteries for an external range extender. It has 2,500 milliamps. I did a check with this one while riding it. I can take out 3,500, also 3.5 amp hours, 3,500 milliamp hours out of this battery. So it's 1,000 milliamp more netto, which I can do with this one. And the other battery, the LiFePo, the original one, which you could use for an external range extender, which you could empty completely because it's the same range of voltage, would cost you at least double the price, and the batteries are slightly bigger. It's not 21, it's 26. So the whole block will become bigger, it's more expensive, and you have less amp hours. So, well, that's why I choose this battery. Well, this is my opinion, and I totally understand if there's 100 different opinions. I will show you the rest of the video when I take out the printing out of the resin printer, when I put in these batteries into the new box. And I'll show you more when I install it and test ride it. So I hope you enjoyed the video so far, and it continues in a few seconds, hopefully.